Assalamualaikum students. Students, in this class we are going to do electrolysis. Now, what is electrolysis? It's a this you have done in your O levels, right? It's continuation of this, but here we can relate this to electrode potential values if we want, right? So, what is electrolysis? It is decomposition of an electrolyte, which is either molten or aqueous by the passage of electricity. So you have to provide power source, you have to provide electricity. So what you are supposed to use? The battery, the power source, and in this case, it is a non-spontaneous redox reaction. There is a non-spontaneous redox reaction at the cost of this power source. Right? This is what? Power source. So, for electrolysis, E cell is always negative. Keep in mind. So, it's not occurring on its own. It is occurring by the provision of potential difference across an electrode. Like you have to provide potential difference. You have to provide electromotive force for this reaction to occur. So your electrolyte is, I'm going to explain this bit. Your electrolyte is molten or aqueous, having freely moving ions. For example, I have this NaCl molten. I'm using molten NaCl liquid. And how much potential difference I will apply to make this reaction to occur. So there is this Na plus in this, and what you did in your O levels, the cation moved to the cathode, they gain electron. The Na plus moved to the cathode, gain electron, turning into metal. Agree? The chloride moved to the positive. The chloride will lose electron, making what? Chlorine, green yellow gas. Your electrolyte get decomposed. Agree. But if I relate this to electrode potential values, look. Na plus gain electron, making what? Na. It is something minus 2.7. I'm not 100% sure, but it's close to this, right? And chlorine gain 2 electron, 2Cl negative, plus 1.36 volt. Now, this is Na plus, this is Na plus, this is the chloride, the molten. Now, Na plus is going to gain electron at cathode. And chloride is losing electron. But do you think Na plus can gain, or the gain one have larger E0 than the lose? Yes. For spontaneous, the one that is gaining has larger E0 than the one that is losing. Right? So the one that is gaining, its E0 must be larger than the one that is losing. But its E0 is less. So this reaction is not occurring on its own. The one that is gaining, its E0 must be larger than the one that is losing. That's not the case here. So this shows that this is not occurring on its own. We have to make this reaction by force. How? By provision of the potential difference. So, if I calculate that how much potential difference should be applied, right? It's kind of endo situation. So, the Na plus gain electron making Na minus 2.07, the chloride lose electron making chlorine minus 1.36. Multiply this with 2, the electron cancel, 2Na plus 2 chloride making what? 2Na and green yellow gas, and the E cell is how much? 6, 2, 3, and 4. Is it minus 0.406 volt? What this minus shows? Not spontaneous. So means provide 4.06 volt potential difference across the electrodes to run this reaction. So you have to use a power source in this place which can provide potential difference of 4.06 volt potential difference, right? For all the electrolysis and electrolytic cell, the E cell is always negative, right? Now, we have two types of electrolyte. What are the two types of electrolyte? Your electrolyte, your electrolyte could be molten and could be aqueous, right? If it is molten, for example, molten aluminium oxide, it contains aluminium ion, oxide ions at cathode. Cations at cathode, it will gain 3 electron, making aluminium, and at anode, anion, 2 oxide, lose 4 electron and oxygen gas. But if your electrolyte is aqueous, keep in mind, it could be dilute, it could be concentrated. Dilute and concentrate. So we have to go to the electrochemical series that we used to do in O levels. Electrochemical series. Huh? What is that electrochemical series? It is for cations. Look. Cations. In cations, it is Knights of Norway called Mr. Asif. It helps you a lot, right? So memorize it this way. Knights of Norway called Mr. Asif Zardari from Sindh, Pakistan. He has copper, silver, and gold sufficient. You know, in cation, always means concentrated, dilute, aqueous, whatever it's written. Always lower cation gain electron. So if there is H plus and tin, which one is going to gain electron? H plus and zinc, H plus and copper. Always lower cation will gain electron. But in anion, look, in anion, this is fluoride, sulfate, nitrate, chloride, bromide, iodide, and hydroxide. These three can never lose electron if OH is present, right? But these three can lose electron if your electrolyte is concentrated. And this is always in dilute. I want to explain these upper ones. Look, why concentrated? Like if I take the example of fluorine, fluorine gain 2 electron, 2 fluoride, it's something, its ENOR value is 2.78, I think. I'm not 100% sure, but it's kind of this. Sulfate gain 2 electron. No, sulfate. It is S2O8, 2 electron, 2 sulfate. It is something 2.01. Chlorine gain 2 electron, 2 Cl negative, 1.36. Bromine gain 2 electron, 2 bromide, 1.07. Iodine gain 2 electron, 2 iodide, plus 0.54. And O2 plus 2 water and 4 electron. 0.40 volt. Now listen. If you have this fluoride, you have sulfate, and you have OH, which one is going to lose electron? Definitely OH, the one that is lower. The one that is lower, having lower E0, will lose electron. Like if this one is going to lose and this one is going to lose, this one is going to lose, which one is going to lose? The one with the lower E0. Look, this is fluoride and sulfate. Their E0 values are so large that they cannot lose electron in presence of OH. It's OH that is going to lose. What I did, I increased the concentration. When I increase the concentration, the equilibrium shift to the left-hand side. This value decrease, but still lower than 0.4. So do you think even if I make them more concentrated, and if I want to shift the equilibrium to the left, still they are not going to lose electron if OH is there? So these three, their E0 values are so large that even if you increase their concentration, you can't bring their E0 lower than 0.4. So they're not going to lose electron if OH is there. But you know what about these three? These three, if you will increase their concentration, what will happen? Concentration increase. The equilibrium will shift to what? To the left, to the left, to the left. You know, it decreases. It decreases and gets lower than that of 0.4. Lower than 0.4. So if they are concentrated their inert value decrease and get lower than 0.4. So these three cannot lose electron in the presence of OH. So they never discharge. These three can lose if it is concentration, otherwise not. Like in dilute, it will lose or this, definitely 0.4. In dilute, this or this, definitely 0.4. But if they are concentrated, you can make their E naught values to be lower than 0.4. So if I go to this question, look at this. Huh? Like this is molten. In molten, it is lead, it is bromide, substance at anode. At anode, what? Bromide. So bromide will lose electron, making what? Bromine. At cathode, lead 2 plus gain electron. It's lead. So the answer is lead and bromine. Now it is concentrated. So Na plus chloride, H plus OH. Among Na plus H plus, which one? Among Na plus and H plus, it's always the lower one. H plus. In concentrated, is chloride or OH? Definitely chloride. So what are you supposed to write? Huh? It's H plus that will gain electron at cathode. So 2H plus gain 2 electron hydrogen gas liberated. Among chloride and OH, it's chloride. So the chloride lose electron making green yellow gas. And what is left? NaOH. So you are having what out of this? You get hydrogen gas, you get chlorine gas, you get NaOH. Now coming here, copper nitrate. It's copper, it's nitrate, it is H plus and OH. So among copper and H plus, which one? Copper and H plus? Copper. So copper is going to gain electron. And among nitrate and OH, nitrate can never lose electron. So it's OH. So at cathode, copper will form. At anode, 4OH negative, lose 4 electron to water and oxygen. So what is formed? Oxygen. And what is left? HNO3 is left. Huh? Like look, again, this is silver and this is what? Silver, nitrate, H plus OH. So it is Ag that is lower. Silver metal, OH. So it's oxygen gas and HNO3 is left. Same, and copper sulfate is same, like this is copper, this is sulfate, H plus OH. So copper will go, oxygen, and what is left? H2SO4. There is this question from 2011. This is the question of 2011. In this question, the only issue is that they have used the word aqueous solution. They have not made it clear. But after that, all the questions are very clear. Like there is no confusion. There are many questions like this. You can see this dilute concentration. It's clear cut written. Right? There is no issue. But in that question, when you use the word aqueous, like suppose it is Ag plus, fluoride, H plus or H. In cation, it is always the lowest. Fluoride can never lose its OH. So it's a silver metal and it's oxygen gas, and what is left? HF. Now if we SO4. It is Fe, it is SO4, it is H plus, it is OH, hydrogen will is lower than Fe. This OH, SO4 can never lose electron. So it's oxygen and hydrogen gas. Now it is MgBr2. They have not mentioned it's concentrated dilute. So if this is not mentioned, go for concentrated always. It's Mg2 plus, like treat this in this is like Any aqueous is treated like concentrated only in electrochemistry. Otherwise, dilute only in electro. You'll get your answer exactly the one that is given in mark scheme. But that is only in electro. Otherwise, aqueous means dilute. But here, if you will treat this concentrated, your answer would be perfectly like that of the mark scheme. See, Mg and bromide, H plus and OH, and I know it's H plus, Mg is way above the series. So, hydrogen gas, bromide and OH, it concentrated is bromide, and you will get bromine, it's the part B of what? 64C. Look, bromine and hydrogen. So I hope you understand. In the next lecture, I'm going toward the calculation, the times, the impair this. So that would be my last lecture, I think, of electrochemistry. Okay. So see you in the next lecture, and don't forget to like, subscribe, and share my channel. Allah Hafiz.